Welcome to DWBI Adda channel. Please subscribe for latest training videos.
Hello and welcome back everyone to another video in the series of machine learning with scikit-learn. And in this video we'll be touching the one of the most famous classification and one of the best classification algorithm, that is the random forest classifier. Now in this video we'll be looking at what is decision tree and what is random forest classifier and what makes it one of the most popular classification algorithm for any given data. So let's get started. So the notebook is ready. And what is decision tree? Now for a given instance or for a given classification, a decision tree divides the decision of or the category of the data into specific values for each instance, dividing it like a tree structure of two binary formats always, and coming to a specific result. Now we have made another video on decision tree completely featuring that, and I would suggest you to look into that. But that was the overview of decision tree. And what happens in random forest classification is that it takes a specific number of decision tree which has been applied to the same data. Once that is done, it takes the result out of all of them and then gives you the result. Now it's a combination of several decision tree which is passed according to the number decision of the tree that we want to pass in our algorithm, and that makes it one of the best preferred algorithm on the Kaggle platform by the data scientists. Now as you can see, random forest was as much as popular as artificial neural network at a point of time, because what happens is it works one of the best suited category for the given data and have one of the best predicted results. So let's get into the classic data that we have been handling, and let's see how much a result score that we can get from a random forest classifier. So I'll be importing the necessary libraries, and we are using the classic iris dataset in the same. Now we have used iris dataset in a couple of other classification algorithms also. So we are comparing the different results that we can get on a given same data by applying different algorithms. So we'll be loading the iris dataset from the dataset subclass in scikit-learn. Now scikit-learn does provide some of the datasets for the training testing purposes, and iris dataset is for the same. Now iris is the flower, and basically classified into three different types on the basis of the sepal length, and we'll be trying to classify all three of them on the same basis too. So from load iris, we take the data into iris and take the x value from iris data and y as iris target. Once that is done, now since the data is been directly taken from scikit-learn, the data is passed and clean, so we can just directly move forward to make the test train split. Now test train split is one of the very important part when a data is given to you as a whole, because then you have to divide the data accordingly and you have to make it for the testing and the training purpose from the same. So in that you dedicate most of the data to the training purposes and take a part of data for the testing one. In this one, we are passing the x and y values and taking 20% as the test size from the complete dataset, followed by a specific random state of 42. The number can be anything, but taking a specific number at each time helps us to get rid of the bias of the data that can be obtained. So we'll be executing that. Once that is done, we need to standardize the value or the data which is present, allows the model to have better accuracy and prediction values. Now once your data is ready, it's time to call the model and implement or train the model for the same. So in this one, we are calling the random forest classifier in the class of ensemble. Now ensemble is the concept driven in the concept of random forest, and the random forest classifier and regressor both are present inside the ensemble subclass of scikit-learn. Once that is done, we call the random forest classifier followed by the number of trees, you can say, or the n estimators. These value can vary according to the value that we want to provide, so it can be 1 or even 100 or 10 for now. The criterion that we are passing is the entropy. We have different kernels and the values for the same, and the random state we are passing here is 0. Once the instance has been made, we fit the data of X train and Y train and then execute the code. So all the default values have been taken, and it's now time to test the predicted values. So here's the Y test that have been separated from the data, and here are the Y predicted values from our classifier. So as you can see, we can see a lot of similarities between the data which has been provided, and let's compare them for the results. Now for the results will be, there are two major ways for which the result can be visualized. The first one is analyzed. The first one is the visualization of the data and then looking at the output, or the second method is to look at the numericals which suggest how much precision or the bias or the model performance is being given, and that is through confusion matrix in a classification data. So we'll be calling that from the subclass of matrices and implementing the confusion matrix. Now as we can see, the three different types of targets that we were having, so we are having a 3 by 3 confusion matrix, and it gives us the value only in the diagonal, saying that the values got predicted exactly the way they were in the target variable. That means by the time we try to look into the accuracy score, we can say we obtained an accuracy of 1. That simply means the value that has been distributed for Y test and Y predicted values have been equally and exactly the same. So your model has been perfectly trained and has given you the best results from the same. So as you can see, we obtained an accuracy of 1 as compared to the other algorithms that we have implemented in this series of for classification. Random forest has given us the best result which can be obtained, and by far this is the best one that we have obtained. So that was one of the reason why it's one of the most preferred classification algorithm on Kaggle. So yes, and it has the simple ensembling of the best way it can happen by taking the result of all of the classification that happens, and then you take the best results out of them, clearly giving us the best results in the same. And that was random forest classifier, and see you in the other videos. Bye.